Today we're going to be proving that the arc of hyperbolic cotangent of x is equal to half times the natural log of x plus 1 divided by x minus 1. To start off, we know the definition of the cotangent of hyperbolic of x is equal to e to the x plus e to the negative x divided by e to the x minus e to the negative x. We're going to assume this outcome to be equal to a, which by definition we can then find x by definition, the arc cotangent of hyperbolic of a. And now we're going to be analyzing this equation. That is e to the x plus e to the negative x divided by e to the x minus e to the negative x is equal to a. We're going to assume e to the x to be equal to n. Then we substitute to get n plus 1 over n divided by n minus 1 over n is equal to a. Then we combine to get n squared plus 1 divided by n squared minus 1 is equal to a as well. We multiply n squared minus 1 on both sides to get n squared plus 1 is equal to a times parentheses n squared minus 1, which is equal to a n squared minus a. From here, we can subtract n squared on both sides and a to get a n squared minus n squared is equal to 1 plus a. We factor out n squared to get n squared times a minus 1 is equal to 1 plus a, with n squared being equal to a plus 1 divided by a minus 1. Remember our previous assumption of letting e to the x be equal to n. Therefore, we can put it back into the n variable to get e to the 2x power is equal to a plus 1 divided by a minus 1. To find the value of 2x, we take the natural log of a plus 1 divided by a minus 1, divide 2 on both sides to get x is equal to half times the natural log of a plus 1 divided by a minus 1. And now, likewise how we did it for the arc of tangent hyperbolic of x, we must argue the restrictions of a. But before we do that, let us finish this proof by remembering our definition right here. X is equal to the arc of hyperbolic cotangent of a. Substitute that into the same x variable right here to get the arc of hyperbolic of cotangent of a is equal to half times the natural log of a plus 1 divided by a minus 1. And now we are almost done. We just need to find the argument for the restriction of a. Like how we did it for the arc of tangent hyperbolic of x, we'll do it for the same thing for the arc of cotangent of x. To start, a minus 1 can never be equal to 0. A can never be equal to 1. Furthermore, when a is equal to negative 1 plus 1 divided by 1 minus 1, or negative 1 minus 1, will give us 0. And this won't be true because e to the x will always be greater than 0. X will be all the real numbers. Therefore, when this is equal to 0, when a is equal to negative 1, won't make sense. Therefore, a cannot be equal to negative 1. And that applies true for only these two scenarios. All the other numbers would work. Why? Because let us take an example right here for a plus 1 divided by a minus 1. The first scenario, a is greater than 1, such as a is equal to 5 and a is equal to 4. When a is equal to 5, this will be equal to 6 over 4, which will be equal to 2 or 3 over 2. 3 over 2 is greater than 0, hence it will satisfy e to the x condition being always greater than 0. We can do it for the same thing when a is equal to 4. 4 plus 1 will be 5, 4 minus 1 will be 3. This will be greater than 0, hence this would match our condition as well. And now we move on to our second scenario when a is less than 1. Let us take a to be negative 3 and a to be negative 5. When a is equal to negative 3, this will be equal to negative 2 divided by negative 4, which will be equal to 1 over half. 1 over 2 will be greater than 0. It will satisfy our condition of e to the x being greater than 0. Furthermore, when a is equal to negative 5 plus 1 will be negative 4. Negative 5 minus 1 will be negative 6, will be equal to 2 over 3. 2 over 3 is indeed greater than 0. It will satisfy our condition of e to the x being greater than 0 as well. Hence, we can come back here, and if I clear myself some room, we can find and finish this proof. A will be greater than 1 union a is less than 1, and a is less than negative 1. And this can be rewritten as the absolute value of a is greater than 1. Hence, we have proved this formula of the arc of hyperbolic cotangent of x is equal to half times the natural log of x plus 1 divided by x minus 1, with x's range being greater than 1 and being less than negative 1.